Hey, what's up? Let's do some math today. In this video, we're going to talk about the Pythagorean Theorem. Now, odds are you've already seen the Pythagorean Theorem or part of it throughout your life. A squared plus B squared is equal to C squared. This is pop culture mathematics right here. You see it probably on anything that's sort of like, clip art, or anytime you type in like math into Google and Google Image, you see A squared plus B squared equals C squared. Now, the thing with the Pythagorean theorem is that it's actually a two-part statement here. And so what we're going to do is we're going to take a look at just the first part, the Pythagorean theorem. And the way it works is if, and this is important here, we have a right triangle, which I'm just going to draw for us right here, it has to have that little rectangle there, then a squared plus b squared is equal to c squared. So we have to have a right triangle first, okay? And so a right triangle is a triangle that has a 90-degree angle with that, and it's usually denoted with this little box right here. Now, some more vocab that we kind of need to talk about. So again, let's draw it like this. Actually, you know what? I'm going to mix it up. Sometimes people think that right triangles always have to look like that. They could look like this. C is always going to be the longest component. A and B are interchangeable. They could be swapped if they want, but they are just going to be part of what we call the legs or sides, whatever you want to call it. So legs / sides. But C has to be the longest one of all these, and it gets a special word. It is the hypotenuse. Hypotenuse. And that just means the longest side of a right triangle. Okay, so we'll see some examples of this later, but then let's talk about the converse to the Pythagorean theorem. Now the converse is what we flip things around. So instead of saying if we have a right triangle, then a squared plus b squared equals c squared, we can say if a squared plus b squared equals c squared, then we have a right triangle. And so what we can do is take any side lengths of a triangle and we can plug them in here and see whether or not we have a if we have a right triangle. So if this works, then we have a right triangle. And again, we just have to remember that C is our largest number. Let's not put a number there, let's put it there, number. So sometimes it might be presented out of order, but we always have to let C be the largest number. Okay, so now we're going to use this to eventually find some missing side lengths. But right now, let's focus on what we can do with the converse. And with the converse, we're able to determine if a triangle is a right triangle. So taking a look at some examples down here, essentially what we're looking for is a yes-no type situation. So what we're going to do is take these side lengths and we're going to plug them into the Pythagorean theorem. So this is my largest, so that's going to be my c squared. So I'll go 13 squared here, is equal to 5 squared plus 12 squared. Now here's where it's handy to have a calculator to kind of help you with some of the arithmetic. 5 squared is 25, 12 squared is 144, and 13 squared is 169. When we add these together, we get 169 is equal to 169. Since these are the same, check. Yes, this is a right triangle. Now, let's clean this up, do a new one, let's make it colorful, put a new color here, let's go green. Okay, here, looking at these three numbers, 31 is the largest, so what I'm going to do is let that be c squared, so 31 squared is equal to 15 squared plus 9 squared. So 15 squared is 225, 9 squared is 81, and 31 squared, I don't know off the top of my head, so according to the calculator, 961. I don't think I need to go any further. I can tell this is not going to be 961, but for good measure, 225 plus 81, it is 306, and that does not equal 961, so no, this is not a right triangle. Now, I want to show you a slightly different look to this. Let's box that up again. Okay, I want to show you a slightly different look. Sometimes you might be given answers in radical form. Now, if you're not sure what that is, you can type it into your calculator to see what root 33 is, and that is about 5.7, give or take, meaning 7 is my largest. So 7 is going to be my c squared. So I have 7 squared is equal to 4 squared plus square root of 33 squared. Now here's why I have this example in here. Square root of 33 squared is just 33. The new color. This and this cancel each other out. And all we're left with is the 33. Plus 16 is equal to 49. All right, and here we get 49 is equal to 49. So even though it looks weird, we can still plug it into the Pythagorean theorem, find out that it works, and say, yes, it is a right triangle. All right, and then let's take a look at this last one. New color, there we go. So 5 is my largest number, so that's going to be c squared. So 5 squared is equal to square root of 2 plus 3 squared, and square root of 2 is squared. So again, this is just going to give me 2 plus 9, and that does not equal 25. And so I put this in here just to kind of show you that you see 2, you see 3, you know you have to do some adding, and you see a 5, you think it's going to work out. But apply the formula, and you realize it does not work out, because 11 does not equal 25. So no, these are not right triangles. So that's one thing we're going to do, is just determine whether something is a right triangle. Next, we're going to use the Pythagorean theorem to find some missing sides. Now, again, I'm going to kind of highlight it. This could be A, this could be B. A and B don't matter because these are the legs of the triangle, but this part has to be C. We see that we have a right triangle symbol, so that means that I can apply the Pythagorean theorem. A squared plus B squared is equal to C squared. And again, we can use calculators, and that's going to make life a lot easier for us. So here, I'm going to go 7 squared plus 15 squared, and this is equal to C squared. Crunch those numbers. Let me zoom in here. We'll get 49 plus 225 is equal to C squared. 225 plus 49 is equal to 274. Now here is where we have two possibilities. This is equal to C squared. So if we want C, we're going to take the square root of both sides. So C equals square root of 274. On one hand, we could just box it, walk away. Or we can get a decimal approximate of this, and that is about 16.6. So you got to read the instructions and see what they're asking for. Do they want it in radical form? Or perhaps unsimplified form, or an exact form is another way you could maybe see this, because that is an exact answer, whereas this answer is a rounded answer. Or they might say, hey, round to the 10th, round to the 100th, round to the nearest whole number, depending on context. So that's how we use the Pythagorean theorem to find the hypotenuse. Now let's find some other sides. So again, this is new color again. This is the longest side, so this has to be C. And this is A and B. So with this one, what we're going to do is just plug the stuff in. A squared plus 13 squared is equal to 19 squared. We're going to solve for A. So A squared plus 169 is equal to, I should know this, 361, but I'm just going to double check, 361. Subtract 169 from both sides, and we'll have A squared is equal to, let me see, minus 169, 192. Okay, again, a lot of students will either leave their work here and be like, I'm done. Remember, we have to take a square root. So we could say that A just equals square root 192, or we could get the decimal approximate for that, which is roughly 13.9. And that's what would go here in our missing side, 13.9. Last one, I want to show you one with a radical. just to kind of show you again, nothing really changes here. So this is our longest side, so this has to be C. Again, I can pick A or B. In this case, I'm going to solve for B. So I'll have square root of 11 squared plus B squared is equal to 25. Oh, sorry, I jumped the gun there. 5 squared. Take our time, simplify. So again, squaring a square root cancels that out. We're left with just 11 plus B squared is equal to 25. I need to get this by itself, so I'll subtract 11 from both sides, and B squared ends up equaling 14. Again, don't forget, take the square root of both sides. B could equal the square root of 14, or if we were to use a decimal equivalent, that is roughly 3.7. And there we go. That's how we do the Pythagorean theorem. It's all about being able to do little a squared plus b squared equals c squared. We have the actual Pythagorean theorem, which is this conditional statement. We have the converse of it, which helps us determine if we have a right triangle or not. And we can use the Pythagorean theorem to find some missing sides, whether it's the hypotenuse or one of the legs. So good luck on your practice, and let me know if you have any questions.